what I'm going to do. I'm going to use the sum and difference identities. So I look at tangent, and I look at the formula. And I say, all right, I got my u plus my v. And basically, I am just going to replace all the u's with 5 pi over 6 and all the v's with pi over 4. Does that make sense? I mean, it's rather simple. I mean, you have the formulas right in front of you. You have the angles. And you're just going to plug them in. Where people make the mistakes is, especially with tangent, is doing the evaluating the unit circle as well as the simplifying. So that's where we got to be careful.
How do we decide which sign goes on the bottom?
What do you mean?
Of the fraction?
Well, if it's the sum of two angles, then you subtract. If it's the difference of two angles, then you add.
Okay.
So it's always like the opposite sign. You can also think about it that way. OK? All right, so let's go and do this one. So if we do this one, dang it, this is the exact same. All right. I didn't really mean to do this one, but either way. If we do this one, no, it's the exact same as what your warm-up was. What's the tangent of 5 pi over 6? Oh, no, it's not. It's a little bit different. So let's go and look at 5 pi over 6. Now, sometimes tangent is a little bit more difficult, or as far as understanding on the unit circle. So 5 pi over 6 is over here. That means 5 pi over 6 is over there, right? So the coordinate point is here, square root of 3 over 2, comma 1/2. If I put 1/2 over square root of 3 over 2, I've done this so many times, it's square root of 3 over 3. But it's over here, so that means it's negative, right? So it's negative square root of 3 over 3. And then tangent of pi over 4, that's going to be plus 1. All over 1 minus tangent of 5 pi over 6, again, is negative square root of 3 over 3. I would recommend using parentheses here so you don't get that messed up. And then times 1.
Can you explain again slowly how you know when to use the plus or minus? Like which one use?
So like it's like
I'm pretty sure she has one.
I'm pretty sure. So it's like see how it has like a plus and a minus. So you just basically match it up.
Guys, yeah, just follow the pattern.
Shut up. Serious.
Okay, we can all work together.
All right.
I don't know. You're annoying.
OK, we'll cover that. Let me finish this, and we're going to do some examples. All right, so now I can simplify this. And I'm going to kind of go to the right, even though I really don't like going to the right. But by simplifying this, I get negative square root of 3 over 3 plus 1 all over 1 plus square root of 3 over 3. And guess what? Doesn't that kind of look like similar to our warm-up? Yeah, so we could multiply the top and bottom by 3 to get rid of that 3 in the denominator. And by doing that, I'm also going to rewrite this around because I like the radical at the end. So therefore, this becomes 3 minus square root of 3 all over 3 plus square root of 3. So what I did is I switched those around just because I like having the radical at the end. So now I can rationalize the denominator. So I'll multiply by 3 minus square root of 3, 3 minus square root of 3. And when doing that, I'm going to do this in my head because that's a perfect square trinomial. So that's going to give me 9 minus 2 square root of 3. And therefore, that gives me positive 3 all over my denominator, which is a difference of 2 squares, which is 9 minus 3. Now let's just go and simplify that. That becomes 12 minus 2 square root of 3 over 6. And now 6 doesn't divide into that 2, right? What?
Wait, why is the negative round 2? Why is it not negative 6 round 3?
I don't know. Hold on a second.
Speaking,
Oh, it is 6. Yeah, thank you. That is 6. Thank you. Good catch. So therefore, the 6 does divide into both. So that'd be 2 minus the square root of 3. Yes?
The only part like I got lost on was when you multiply by the 3. How do you get rid of, is it, when
So-
you multiply by the 3s, isn't it like 3 over 1 basically?
Yeah.
And so how do you get rid of the 3 on the bottom?
Well, 3 over 1 times this is negative square root of 3 over 3 times 3 over 1. 3's divide out. right? But then you have to multiply 3 times that, which gives you 3, because you got to multiply both of them. Anybody have any other questions?
Yeah, you got positive 3 instead of a negative 2.
Yeah, because 3 times 1 is 3.
Uh-huh.
So instead of writing it at the end, I just put it in the front. It's the same thing as when you multiply by 3, you get negative square root of 3 plus 3, right?
Uh-huh.
I just switched them around
Why?
because it's easier for me to multiply when it's like that. Okay. You don't have